Tuition Mobile, quality e-learning experience on the go.
You're welcome back to the class. For this section, we'll be talking about bearing and distances. Bearing and distances. And so, in bearing, we'll be considering the following. One, we'll be considering degrees of angles. These are things you should know. We're seeing that degrees of angles are measured. Degrees of angle are measured counting from the north. Okay, and then you should know that the relevant directions are the 4 coordinate points. Relevant directions are the 4 coordinate points. Cardinal points. Okay. And then this topic requires a proper understanding of solutions of triangles. Requires a proper understanding of solutions of triangles. Okay, and so the concepts guiding this topic are based on things we know previously, and without wasting time, we will try to apply them in this. We will solve using examples. For example, number 1. Okay, a boat sails 6 kilometers. So 6 kilometers from a port X. Okay, on a bearing of 65 degrees, and thereafter these same boats on a bearing of 136 degrees sails 13 kilometers. A bearing of 136 degrees. Alright, so what is the distance and the bearing of the boat, and the bearing of the boat from X. Okay, that's our question. And so the first thing we'll do is to start to map out these points. Remember what we said? We said this bearing starts from the north. The counting starts from the north. The boat sails from a port X. Okay, assuming this is our X. This is a port where you have X. Okay, you fix your 4 cardinal points. Okay, and then counting from the north, the 4 cardinal point is north, south, west, and east. Okay, right, and the total angles on this point 360, where each segment has a total of 90 degrees. And so counting from the north, you have movement along the north side here, and we say that where the movement stops is where we have 65 degrees. Okay, at this point we have 65 degrees. And so just like the question says, that the boat sails from a point X on a bearing of this of 65 degrees, and thereafter when it's now at this point, okay, we are told that on another bearing it sails to a different direction. Okay, so if this is where it stopped, it's moved from another bearing. Remember what we said, each cardinal point segment is 90 degrees. So here is 90 degrees, here is 90 degrees too, here gives 90 degrees, here gives 90 degrees. Okay, so the total is equal to 360 degrees. Alright, why we are doing this is because when we want to locate points, okay, assuming we want to locate points on a bearing. Okay, alright, after this illustration I'll make you understand better. Alright, you see the bearing, the movement of the boat moves and then it crosses 90 because it is 136 degrees, and 136 degrees falls in the second part where you have the southeast, and since it has entered that other part, alright, so this is our 136 degrees, and so what will remain between this and this? What will remain? Remember that from the theory of angles, alternate angles, 65, and so here becomes 65 degrees. And then since this is 136 and the total angle that should be here should be 90, so we should have 90 plus 90 minus 136 to find the angle left out. And so 90 gives 180, and then minus 136. What do we have there? We have 180 minus 136, and then it gives us 44 degrees. 44 degrees. And so the total angle under this part is adding the two, and then you have 44 plus 65 to give 109 degrees. 109 degrees. Okay, so this is the point where the boat sailed and stopped. Alright, and the question here says we should find the distance of separation. We should find the distance of the boat. Okay, assume I call here x and this one y, and then at this other point z. And remember, the boat sails 6 kilometers from the port to the first point, 6 kilometers, and then from the next point it says 13 kilometers to z. Alright, so this is the pictorial depiction of what the question is. Alright, and all we have to do is this. We have to find the mixing angles and the side. The first question says we should find the side because that's the question for distance between x and z. So we have two sides, two angles. We have two sides and one angle, and then we need to find the side xz. Alright, we can find that using the cosine rule, and the cosine rule states that if the side you're looking for, if you have the missing side, you can go back to your cosine rule. The missing side xz squared is equal to the square of the known two side xy, okay, and the yz, okay, squared minus 2 times the multiple of the known sides yz, okay, and the cos of the missing side xz squared, right? So cos of xz, fine. And so we have that xy there is 6 kilometers, like 6 squared plus 13 squared minus 2 times 6 times 13, and then cos of z, cos z is cos of 109, cos 109 degrees. Okay, alright, this is xz squared. Okay, and so we know that 6 squared is equal to 36. and the 13 squared is equal to, you can use your calculator, 169. Okay, and then 2 times 6 times 13 gives us 156, and then cos of 109, you do this separately, gives minus 0.326. all right, for this type of questions, you don't say 156 cos 109, you find their values separate. And so when you add these two values, you have 205. Okay, and then this gives you minus 156 times minus 0.326. okay, minus minus gives us a plus, and so the chart sign changes. Minus takes care of minus. Okay, and then the two of them changes to plus also. And then 156 times 0.326 gives us 50.856. And so when you add these two values, you have 255.86. all right, and which says that xz squared is equal to this. So xz itself will be equal to square root of the value we have here, 255.86. all right, and so when we take the square root, xz will be equal to 15.99, which is approximately 16 kilometers. all right, so we go back and write this as 16 kilometers, and then we can say therefore the distance between the two, therefore the distance xz is equal to 16 kilometers. all right, so now we shall try to define the angle, define the bearing of z from x. B section says find the bearing of z from x. all right, and so to find the bearing of z from x, we shall use the sine rule. okay, we shall use the sine rule to discover the bearing of x. Look at the bearing. This point here you have said, these are bearings. At this point, this is the bearing from x to z. This is the bearing. So how do we discover that bearing? all right, we start by finding the side, the angle on z, assuming we call it theta. And so we go back to a sine rule. We say sine theta all over 13 kilometers is equal to, you can use any reference point where you have a side and an angle. So but I just have one point, which is y, with a side and an angle 155.9. all right, you can cross multiply. At this point we have that 13 sine 109 degrees is equal to 15.99 sine theta. okay, and so you have this sine 109 theta is equal to 15.99 sine 109. I think there's a mix up here. all right, so I have I want to bring 15.99 sine theta to this side, and then this is 13 sine 109 degrees, so that sine theta will be equal to 13 sine 109 degrees all over 15.99. fine. And so if you carry out that computation, you will have that 13 sine 109 is equal to 12.2917 divided by 15.99. 99, so that sine theta will be equal to 0.7687. Okay, to the next slide, so that theta will be equal to sine inverse of 0.7687. okay, and so theta is equal to 50.24. alright, which is equal to 50 degrees. And so we're saying that this part theta is equal to 50 degrees. Alright, so how do you find the bearing of x to z? The bearing of x to z is this angle. The angle that flows from the point from x to z. Alright, this is x. Okay, I want to make a bigger picture of x. This is point x. Okay, and the bearing of x to z is this. Is the movement from this point to this point. This becomes the bearing of x to z. You can see the movement we have there, and so it becomes the bearing of x to z. Alright, okay, and so we go back and say therefore the bearing of x to z will be equal to 50. Alright, what did we do? Let's check back. Alright, there is a little omission here. Alright, it is theta is at this point we had 50. Okay, and so the bearing becomes 50 plus 65. Okay, so the bearing from x to z is 50 plus 65 degrees, which is equal to 115 degrees. Alright, so we make the possible corrections, and then what would the angle here be? The angle here, beta, will be equal to what? Remember what we said, the total angle in a triangle is 180, and then minus the angles we have. Okay, we have 180 minus 109, and then minus 50 to give us 21 degrees. Alright, and so this is how you compute this. Sorry for the mix up. When we take the next example, you will understand better. Okay, one more thing we wanted to explain is this. That the fact when you want to take your bearing, maybe if you're given a bearing of 120 degrees, okay, is represented this way. This is your cardinal point, and then when you move from this point to this point, you have 90 degrees, and they don't make up to 120, which means 120th point would be at this point in between 180 degrees. And if you have all these points to be equal to 120 degrees, it means that the points left here is 180, because 90 makes 180, then minus 120 to give you 60 degrees. I hope you understood that. And then if you are given a bearing of 70 degrees, you can draw on the first cardinal, on the first segment, because this segment can accommodate 70 because it's 90. Then you have 70 degrees, and the one left here will be 90 minus 70 to give you what? 20 degrees. I hope you understand that. Fine. And then we have alternate angles. And then if the alternate 70 comes to this point, and then 20 comes to the point where the 70th mark are. So this shows example of alternatives. alternate angles. Alright, so we'll be using these properties to solve questions in our examples. Alright, we'll take example 2 and then we'll end the class at this point. Example 2 states that an aircraft takes off from an airstrip at an average speed of 20 kilometers per hour. Alright, and on a bearing of 52 degrees in 3 hours. Okay, and then you're told that it then changes its course, and flies on a bearing of 28 degrees at an average speed of 30 kilometers for another 1.5 hour. Alright, you are told to find the following. You find it distance, find its distance from the starting point. Okay, and B, you are told to find the bearing of the aircraft, from the airstrip. Okay, so how do we do this? We start with our solution by drawing the bearing of what happened. An aircraft, we are told, takes off from an airstrip. Suppose this is the airstrip, we call the airstrip P. Okay, and then it takes off from the airstrip and on a bearing of 52 degrees. You have a bearing of 52 degrees from this point. You have a bearing of 52 degrees, and then this is our aircraft. Alright, this is 52 degrees, and so we are told that on a bearing of 52 degrees, and we are told that it travels for 20 kilometers per hour on a bearing of 52 degrees. This is 20 kilometers per hour. Okay, in 3 hours it then changes course and flies on a bearing of 28 degrees. In 3 hours, maybe at this point now, it changes course and then flies on a bearing of 28 degrees. Okay, alright, so we are told to find it changes courses at 28 degrees, and then let us call this point where it changed course as P, O, and the point where it stopped as M. Alright, so we are looking for the distance of separation. This is the distance of separation we are looking for. Okay, these are the two distance of separation. Fine. Alright, so I think to make the diagram look better, I think we have the point P and then a bearing of 52 degrees, and then it gets to this point O and then changes course to a bearing of 28 degrees. Alright, to this point M. Okay, and then 28 degrees. You have to find the distance of separation. This is the distance of separation. I hope I could get a straight line. What I'm just trying to show you is that this makes a triangle. Okay, good. You thought that this side travels for 20 kilometers per hour, and then in 3 hours it will travel for 20 kilometers times 3. Okay, which will give 60 kilometers. Alright, so in 3 hours this must have traveled for 60 kilometers at this point, and then this at this other point it says that it flies on a bearing of 28 degrees to another point at an average speed of 30 kilometers per hour. Okay, for another 1 hour, 1.5 hour. In 1.5 hour, okay, it will have 30 times 3/2, which gives you 90/2, which is equal to 45 kilometers. And so in 3.5 hours it will travel for 45 kilometers. Alright, so we are told to obtain the distance of separation. That's equation number 1. Alright, so before we do that, we have to find out what angle at this point. What's the angle at this point? Already do have this to be 28 degrees. What is the angle at this point? Okay, so we should know that at this point we had it flied for 52 degrees. The whole of this point is 52 degrees, and then the rest of the point remaining here will give us the alternate of this point we have here. Okay, so 52 90 minus 52 degrees will give us the value of the remaining points, which is equal to 38 degrees. So that means the angles left here is 38 degrees, and since it is an alternate angle, we introduce it to this point. We have 38 degrees there. And so what angle is at this point? This is a full angle, and so we have 90 degrees at this point. And so the total angle on O will be equal to total angle on O will be equal to 38 plus 90 plus 28 plus 28 degrees. I don't have space here. I would have written it to be equal to when you add the 3 numbers there, you have 156 degrees. I think that's right. Yeah, so what we are saying is that the total angle at this point is 156. I think the 2 triangles can work now. And so to find the distance of separation, remember we have the angle O and we have the 2 sides. So we'll first find the side, the distance of separation. The distance of separation then is PM squared using cosine rule. Okay, PM squared is equal to the square of the 2 given sides, PO and MO. PO squared plus MO squared, and then minus 2PO 2 times PO times MO cos the missing side PM. Alright, and then we're given that PO and MO are 60 squared plus 45 squared respectively, minus 2 times 60 times 45, okay, cos 156, because that's the angle you have substandard PM. Alright, and so this gives us 60 squared plus 45 squared is equal to 5625. 5625 minus 2 times 60 times 45, which is equal to 5400. 5400 cos 156. Okay, cos 156 is given as minus 0.9135. okay, and so 5625. Alright, so this is equal to 5625 minus changes the point, this sign to positive. Okay, and so when we multiply this, we have 4933.15. Alright, and so when we add the two values, we have 5625 plus 4933.15 to be equal to PM squared. PM squared is equal to 105,858.15. So that PM will be equal to square root of 105,58.15. okay, and so taking the square root of that, we have 102 PM is equal to 102.8. Do your approximations very well, you will obtain that. Alright, so the next thing we do is that this gives us the distance of separation. The distance, this is the distance, this is the distance from the airstrip okay, from the airstrip to the starting point. Sorry, this is the distance from the airstrip to the point where the movement ended. Of termination. Okay, and so the second question says we should find the bearing of the aircraft from the airstrip. This is where the aircraft stopped at M. Okay, and this is the X strip. The bearing of the aircraft from the airstrip. Okay, I think somehow can this be visuals? The bearing of the aircraft from the airstrip is not very hard. No, this is the airstrip, and then this is where the aircraft stopped. It is obvious that, let me try to extend this point. Okay, because this is the where the aircraft is. Okay, and this is where the airstrip is. Okay, so if you want to move to where the aircraft is, you take a bearing of this, right, to meet the aircraft. Okay, you take a bearing from the airstrip from this point to this point so that you can meet the aircraft. Fine. And so how do we find this bearing? How do we find this bearing? Alright, we go ahead to find this bearing having a knowledge that having a knowledge of this point here. If you can find the point at this triangle, and then we can find the bearing. So let's find theta here. Okay, this is a place I denoted as theta. Okay, let's find theta at that point, so you can find the bearing of the airstrip. Alright, with that, with theta is having the side 45, and so you can use any point Okay, so you can say sine theta. Okay, we'll be solving using the sine rule. We're using the sine rule. Okay, for solution B part of the equation. Solution B, solving by sine rule. We have the two sides there. We have the theta is fixing XO, and then the side OM. Okay, so we can say that sine of O over OM is equal to sine of P. I want to use P. Okay, sine of is that sine of O? No, that should be sine of P. Sorry, I think this is P. This is P, or not O. Sine of P. Sine of P over the side OM, all over sine of O over the side PM. Okay, with this implies that we have sine P is the sine we are looking for, and the OM is equal to, let's check our diagram, OM is equal to 45 kilometers. 45 to be equal to sine O is sine of O, the point under O, which is sine O is given as 156 degrees. Look at it. The summation of all the points on the part O, 38, 90, 28. So it's given us 156 degrees. Sine of 156 degrees all over the side of O, which is 102.8. This is just the normal sine rule. If you don't understand this, you can go back to our previous topics on sine rule. And so we have that sine P will equal to 102.8. Sine P will be equal to 45 sine 156. Okay, sorry, this is not 45 degrees, it's 45 meters. Alright, so we have that sine P will be equal to 45 sine 156 divided by 102.8. Okay, if you carry out that division, we have okay, if you carry out that division, we have that sine P. I'm not going to go step by step. We want to go through tedious process. We have that sine P is equal to 0.1780, so that P will be equal to sine inverse of 0.1780. Okay, which will give us 10.25. So the angle here, the angle theta is equal to 10.25 degrees. Okay, and so to find the bearing of theta, we add 38 to find this bearing. Okay, should I call the bearing beta? Okay, to find that bearing, remember that the whole of that angle is equal to 90 degrees, and so we have the bearing under the angle as 38 degrees, and then we've obtained theta, the bearing between the angle and the bearing under the angle, as 10.26, or we can say it's 10 degrees. Okay, so therefore the bearing of theta of the aircraft from the airstrip will be equal to, when you subtract, okay, therefore the bearing of the aircraft to the airstrip will be equal to, when you subtract the bearings we have from 90 degrees, because the total angle within that area, it's 90 degrees as shown in the diagram. Okay, we subtract 38, we subtract 10, and then what we are left is with beta. Okay, so I have 90 minus 38 degrees minus 10 degrees, which is equal to 90 minus 48 degrees. Okay, and so we have that the bearing there is equal to 42 degrees. Fine. So this is how you solve your bearing, from which whatever point you are given, you can always arrive to a good value. Just be careful and go back and learn how to work on your angles, know the principles of angles, alternate angles, and the rest of the properties. Good day.